Hi, folks. Happy Friday. So basically what I'd like to do is just spend a few minutes today showing you what happened at Mount St. Helens in the aftermath during that time that you were assessing and analyzing in 2004. Show you exactly what happened. And then once we do that, I'll kind of give you a quick rundown of how to do the quote unquote sketch notes for this week. Just a few small sketches, but mostly it's going to be answers pertaining to and reflections pertaining to what we did with the data analysis in class on Monday and Wednesday. All right, so here we go. It shouldn't take too long, and it should give you a lot more free time to, work on actually getting the answers and things like that. So let me share my screen here really quickly. Boop. And we'll go from there. So what in the heck actually happened here? Well, so there's a great little 6-minute long video clip that I would highly recommend y'all watch. It's from the USGS scientists themselves. So if you go to the slides, you open up today's slides and you click on that link, it'll take you to this webpage right here. It says what happened on Mount St. Helens in 2004. If you could click play, I think it's about 5 or 6 minutes long. So this will give you all of the information that you need and actually put you in the mindset, or at least get you a look into the mindset of the volcanologists and the geologists that were in charge of providing warnings for people at this time. And you'll see they were making very much the same decisions that you all did. I'm going to leave that link to you guys to play on your own, because I know played videos on Zoom recordings can be kind of skippy and sketchy and not that great. So go click on that. Go watch it in its full glory and its full entirety. All right, that's the first thing. So after you watch that, then if you want, you can come back and take a look at this, and I'll show you what exactly happened. Oops, where do we go? So here is what did happen in case you're curious. Basically, on October 1st, so we saw all those earthquakes building up to it. We could see them getting shallower and shallower and things. But on October 1st through October 5th, they started having some steam and ash explosions. And some of the hazards that presented was not necessarily hazards to the towns below, like we see in the hazard maps around here down at the bottom. Let me get my little spotlight here. Not to the towns down here necessarily, but remember this volcanic ash, which is more correctly called volcanic tephra. Remember, it's the broken pieces of cooled magma that get ejected into the atmosphere. Those can get into airplane engines, truck engines, anything that combusts, and it can cause big problems because it's like grit, it's like sand, and it can cause those things to seize up. And you definitely don't want big airplanes flying through this and all of a sudden the engines stop working. So this was a hazard to air traffic, was the main hazard from these steam and ash explosions that were happening. So not all the time were they ash. Sometimes it was just the steam releases. So maybe the snow was getting in there, or there was a little bit extra water, and it just kind of fizzed and made it kind of a gassy eruption just like that. But nothing super huge. So that kind of went through the 5th, and then it kind of got quiet again. And then basically around October 18th to October 17th, there was a lot more dome growth that started happening. And as the dome grew and some of the lava and stuff erupted or oozed out of the ground in this dome, in these lava domes, it caused the surrounding glaciers that were in the crater of Mount St. Helens to start melting. And when that melted, it mixed with all the debris and created some lahars. And the ash flow, or not ash flows, but the lahars, those volcanic mud flows that flowed down into the towns, especially along the Toutle River down here, which I know it's an interesting name, but this is the Toutle River, and there were some small lahars that flowed somewhere in the neighborhood in this vicinity, something like that on the South Fork, and just a little up about towards here on the North Fork. So nothing catastrophic or huge. It wasn't a gigantic eruption, but it did still pose threats for folks living in the immediate vicinity and for those aircraft flying over. And then the other big thing was after that September eruption, that's when we just started having that massive dome growth that happened right here where that glacier was. And so you can see just from, well, September, October, November, December, was that 4 months, 5 months? In 4 months' time, I guess, it went from this to having this big old honking dome in there. And if I remember correctly, the amount of lava that was being erupted to the surface here in these lava domes was somewhere in the neighborhood of like a dump truck every 10 seconds. So imagine like the big, huge dump trucks you might see driving around on a mine site or something. It was enough to fill up one of those like every 10 seconds. So it was a huge amount of volume of that. And so I think I showed this to you when we played our lava dome video at the very beginning when we talked about the different types of volcanoes here, those felsic volcanoes. But here's a cool time lapse. You'll notice there was the 2004 start all the way to 2005. And I'm going to actually make this go a little bit more quickly here. I'm going to go to like 1.5 speed. Boop. There you go. And so it won't take quite as long to play, but you can see that lava dome just building up, gets too steep, it collapses on itself, falls over, and then more lava squeezes up in between and keeps adding and piling up to that dome. And eventually, sometimes they make fins. So what you're seeing right there is like a fin or a spine that comes up, they call those. Eventually, if this happens, these dome building events happen for another 3, 4, 5 years, it's going to fill in more of that crater. It's going to keep filling in more and more. And, 100, 200, 300 years from now, if the rates continue at that same extrusion, or the extrusion continues at those same rates, you're going to basically fill in that Mount St. Helens crater, and it's going to start building the mountain back to looking kind of like a normal composite volcano with a more pointy top, right? So that was kind of what happened there with Mount St. Helens. And so the last thing you can think about then is how does your eruption alert level that you assigned in class. So you gave 2 alerts, right? The first part on Wednesday was at the very beginning of class based on our first 3 poster walks that we did. And then we took a look at some more seismic data and you revised your alerts. So how did your revised alerts compare with what actually happened? And here's a picture of what St. Helens looked like. It's like 2006 or 2007, something like that. But if you want to see a more modern version, I happened to go to Mount St. Helens this summer, and I know you know this because I'm sure I showed you all these pictures. But I'll put a link here in the Canvas page if you guys want to see this. But there's websites, or not a website, tourist center that one of the logging companies runs there. That's pretty cool that you can see all the different bits of how the volcano affected the forests there. It's a pretty neat eruption site center, and then some of the actual visitor center at Mount St. Helens itself on Johnston Ridge Observatory. So when you're looking at those hazard maps yesterday, like this one right here, and we're talking about the Johnston Ridge Observatory, that is, whoops, what you're looking at right here, the hikes from there, which is pretty cool. All right, and then when I was telling you about the Toutle River, lahars that came down the Toutle River and messed up some things. Well, there happens to be this really amazing house on the property of where there's a pretty big Bigfoot. I don't know, what would you call these folks? Folks that strongly believe in the existence of Bigfoot. All right. So I'm not gonna yuck their yum other than to say there's no scientific evidence or proof that Bigfoot exists. But that's their thing, and they make a good tourist dollar having folks stop by. But this house on their property is scientifically incredible because this is the top end of what was an A-framed house. So there's about 10 to 15 feet of house that have been submerged here. And what we're looking at, and let me show you on the map, it's right along the North Fork of the Toutle River right here. And this area right there, was actually smashed by some of the larger lahars from the original Mount St. Helens eruption in 1980. Those lahars came down, and what's kind of crazy about it is those lahars came down and swirled around, kind of in this back channel as it made a turn around this oxbow, or this meander in the river right here. Um, and all of this lahar kind of backflowed in and ended up not hitting the house with full force. Whoops, where'd I go? There we go. Oops, I close that. It didn't hit this house with full force, but it kind of just flowed in backwards like a whirlpool, kind of blew everything in on it, and filled in the bottom layers without knocking the house down. So you can actually go see, just how thick some of these lahar flows were down the river from the 1980 eruption, which is kind of amazing. And then also, if you want to go take a look at the hummocks, or what are some of the landscapes made from this volcano afterwards, you can take a look at that. So in the next the next week and a half or so, we'll be talking about volcanic landscapes. We'll be talking about some of the biggest volcanoes in history, some of the most noteworthy ones. And after we do that, then we'll start heading into earthquakes and things. And by the way, this Bigfoot museum there, they made a big giant statue out of Mount St. Helens. So it's concrete using Mount St. Helens ash and a few other things. So I thought that was kind of interesting. My son liked it a lot too, which is kind of funny. Now, in terms of your sketch notes here, so the last little bit is here are the questions that we basically worked on together in class. So you're just kind of telling me what happened here. What were the things you were talking about? You're just putting your ideas down on the paper here. If you want to type them out, that's totally fine too. But that's the idea with this, So when it says Wednesday's first interpretation of the alert level, take a look at that. Try to remember what we did when we got to class on Wednesday, when we were starting to look at the posters that we'd left all the sticky notes on. That's when we did your first alert level. So that's what you're talking about here. Then the second interpretation of the alert level happened after we looked at those Miro boards, and the link is right here. But the Miro boards had all of the seismic data on there. Once it loads, you'll see them. So in terms of the depth of the earthquakes and the amounts of the earthquakes and things like that. So that's what this one is referring to. And then based on that, we talked about all the damage and what you thought might happen to these different cities in class yesterday. So you're just basically going to write down and recall and recollect, I guess, what you said in class and kind of add that here. So that's the big thing. And then the activity summary, those are your big summary questions. They're not that big, but that's the thing to kind of wrap everything up. And then your only sketches for your sketch notes this week is just give me a quick little sketch and description of how we can use GPS data, seismic data, and LiDAR data to understand volcanic activity. All right, so that's all we got for this week. Pretty short and sweet. So enjoy a little bit of the extra time to be able to piece some of these things together and be thoughtful. And I'll see you on Monday. All right. So have a great weekend, everybody.